right, guys, we're going to look at section 2.1 today, inductive reasoning. So inductive reasoning is reasoning based on patterns you observe, which is something you have already done before. So we're going to continue looking at patterns. So look at example 1. We have 1, 4, 16, 64. How is this pattern changing? Is it increasing, decreasing? And if it is, we have to figure out how that's happening. What is the number that's causing it to change over and over again? So I can see that this is increasing and increasing pretty fast. So I think multiplication. So what can I multiply each term by, the same number, to increase? What can I multiply 1 by to get to 4, and 4 to get to 16, and 16 to get to 64? I can multiply each term by 4. And when I do that, the next two terms would be 256 and then 1024. In number 2, we have circles, and inside the circles we have polygons. So we can see in the first one we have a triangle, then we have a quadrilateral, and then a pentagon. We can look at the number of sides. So in the first one we have 3 sides, then 4 sides, then 5 sides. So the next two should have a circle and 6 sides inside, and then a circle with 7 sides inside. I will show the first one. So here's my circle with 6 sides on the inside. All right, you can try number 3 and 4, pause your screen, and then we'll go over it. All right, so let's look at number 3. So we have that circle, and then inside the next circle has a smaller circle. And then in the third one, we have 2 rings added. So the next one should have a third ring added, and then following a 4th ring. I'll show the second one right here. That would follow the 4th one, 1, 2, 3. So I added that extra ring to the best of my abilities. All right, number 4, we have 16, 8, 4, 2, 1. I hope you see that this is a decreasing pattern and it's decreasing pretty quickly. So how do I go from 16 to 8, from 8 to 4, 4 to 2, and 2 to 1? This one is division, so we're dividing each term by 2. When we do that, 1 divided by 2, that's a half. 1/2 divided by 2, that's a 4th. If you put a decimal, that's fine. Just make sure that you're aware that we can write that decimal as a fraction. All right. Once we're pretty sure we understand a pattern, we can start making conjectures. Conjectures are conclusions made up by using our inductive reasoning. So we're going to continue using that to help us with our next pattern. So here we have a pattern. There's 4 items in it, and there are dots. So in the first one, we have 1 dot, then we have 4 dots, then 9 dots, and then 16 dots. They want us to figure out what would be in the 20th picture. Let's start out by figuring what would be in the very next picture. So thinking about what's going to be in the very next picture, we have to figure out the pattern that we see. From what I see, I can see that we have a square. Look at 16. It is a 4 by 4. And when I mean 4 by 4, I'm looking at those dots. 1, 2, 3, 4. 1, 2, 3, 4. That's a square. If I look at the 9, again, 1, 2, 3, 1, 2, 3. So it's a 3 by 3. For 4, it is a 2 by 2. 1, 2, 1, 2. So that means the 5th term, 5th picture here should be a 5 by 5. If it's a 5 by 5, that would be 25 dots. So what would the 20th picture be? How many dots across and down on the sides? Right, it should be a 20 by 20. So when we multiply them, we should have 400 dots. That's how many should be in the picture for the 20th picture, 400 dots. All right, let's look at the next one. It says try and figure out the 43rd term of the following sequence. The sequence is A, E, I, O, U, A, E. Now, remember, you do not want to write out 43 terms. You want to find the pattern. So pause your screen, try to find the pattern, try to find a quick way to get to the 43rd term. All right. All right, so now let's go over it. So I can see it says A, E, I, O, U, A, E. Well, it looks like my pattern is going to start all over again. So I'm going to take this line right here and separate it. So that means I can see my pattern is in 5. 1, 2, 3, 4, 5. Does everybody see that? So here I have A, E, I, O, U. That's by 5. So I want to figure out what's going to be my 43rd term. So I think, okay, if I repeat my pattern 5 of 5, how many times can I get to 43? Okay, well, 5 times 8 is 40. So that means 41, 42, 43. I'm going to block this out right here. That means I should be my 43rd term. Okay. So again, we're trying to figure out how to get to that pattern. What I did was I used multiplication. Again, I saw that my pattern was a 5. I broke it apart, and then I said 5 times 8. Why did I say 5 times 8? I'm repeating that pattern 8 times to get to close to 43. Could I have used 9? I could have repeated my pattern to 9, and then I had to go backwards 2, and I would still get to I. So that's another way to get to that pattern. All right, counterexamples. Sorry. It says, sadly, not all conjectures are true. You'll need to find one example of when it's not true, and you'll know your conjecture is false. A counterexample is an example that shows a conjecture is false. So give a counterexample for each of the false conjectures. It says, if the name of a month starts with the letter J, it is a summer month. So you have to think, do all summer months start with J? Okay. All right, well, June, July, well, those are J's, but is there a month that's J and not in the summer? And if there is, that's your counterexample. So I have one. It should be January. January is obviously not a summer month, so that is a counterexample. It proves it wrong right away. All right, the next one, it says multiplying a number by 2 makes it bigger. This one's a little hard to understand. For this one, I already put my answer. The counterexample would be multiplying by a negative. Remember, our signs actually change the value of things. So it says multiplying by a number makes 2 bigger. Well, if I multiply 2 by -1, that's -2. -2 is smaller. Negative is a smaller number than a positive number would be. So we have to be mindful of that. That's a nice way to prove that that would be incorrect. All right, so now we're going to talk about conditional statements. Conditional statements are huge. Sometimes we refer to them as if-then statements. I like to refer to them as if-then statements. So it says conditional statements are extremely useful in reasoning. A conditional statement is a statement that can be written as an if-then statement. So here is some examples. It says, if you complete the entire packet on your own, then you will pass the mastery check. So I just want to highlight a couple different things in here. So you can see that we have the if and the then. So here is if and then the then. That breaks up our if and then part. Here you can see it says, if you drink coffee late at night, you will have trouble sleeping. Notice I do not have the word then here. So you make sure you want to add that word in to make it an if-then sentence. Number 3, it says, when Sully stays up late, it's to catch Santa Claus. There is no if or then in this sentence, but we can change that to make that happen. So I'm going to take out the word when. So I just put if, then. It doesn't change the sentence, it just makes it become a conditional. If Sully stays up late, then it's to catch Santa Claus. So again, all we're trying to do is make it an if and then. So then number 4 says dolphins are mammals. How would we change that to write it as an if and then? Well, keep in mind, dolphins come first. That is our subject of our topic. That has to stay in the if portion. Mammals have to stay in the then portion. So here is my sentence. If you are a dolphin, then you are a mammal. The word you, I really just add because it makes more sense to talk about a subject instead of the word if. If it is a dolphin, we really don't want to use the word if at all. We want to talk about who we are talking about, whether it's a person, place, or thing. We want to be more identifying. It is not enough. So I want you to try number 5 and 6. So pause your screen and change these into if-then statements. Okay? So number 5 is quadrilaterals have 4 sides, and number 6 is parallel lines never intersect. It doesn't matter if it's true or false. We just want to change it into an if-then sentence. So pause your screen. All right, so number 5, quadrilaterals have 4 sides. We want to change this. So here is my sentence. You could change it to if the figure, I put if the shape. So if the shape is a quadrilateral, then it has 4 sides. So again, shape is really talking about the item or topic that we're talking about, not using the word it. Okay. In number 6, it says parallel lines never intersect. How we change that? We can change that to if the lines are parallel, then they will never intersect. So again, that's a nice way to break it apart. And you can see parallel stayed in the top part of the sentence and intersect stayed at the back of the sentence. All right. It says each conditional can be broken down into the if part, which we call the hypothesis, and the then part, which is called the conclusion. We say the hypothesis is true, that it implies the conclusion is true. So we're looking at both parts of that. So let's go to the top. I'm actually going to go back up here to examples 1, 2, and 3 to help me identify the if and the then, so I can look at the hypothesis and the conclusion. So in number 1, what part is the hypothesis? The hypothesis is you complete the entire pack on your own. So you could highlight that, or you can write the word hypothesis over it. And then the second part is you will pass the mastery check. So I did not have the box fill in mastery check, but you should fill that in for the conclusion portion. Number 2, you drink coffee late at night. That is your hypothesis. Your conclusion, you will have trouble sleeping. Okay. Number 3, here it says, if Sully stays up late, then it's to catch Santa Claus. What would be the hypothesis? Right, Sully stays up late. Notice I'm not saying if. I'm not including if at all. I'm just including the words in between the if and the then. So I'm just going to highlight that. So that is your hypothesis. Your conclusion is it's to catch Santa Claus. All right, so going back down to the paper, I'd like you to try number 9 and 10 of identifying your hypothesis and conclusion. So you can pause your screen and then try. All right, so in number 9, you should see that Sully shoots the ball. That is your hypothesis. And the shot will be an air ball is your conclusion. In number 10, a triangle is equilateral. That is your hypothesis. It is also isosceles is your conclusion. It's important that you know how to break these sentences apart, so then we can go on to the next topic, still dealing with our if-then statements. All right, so it says, if we have conditional statements, there are several related statements. So these related statements are really important. Let's first talk about negation, the opposite of a statement, usually said not P. Now it says this little squiggly line P. That squiggly line is actually on your keyboard next to the number 1. We call it the tilde. It means not. So that little squiggle means not. So we have a couple things to talk about, and I actually put them on the side here. We have our conditional, that is our if-then. Then we have our converse, inverse, and contrapositive. These 3 words are important, and you're going to be able to identify how to take your if-then statement and turn it into certain ways to make those words happen. So what that looks like. So the very first word, very first line here, and I'm going to highlight it, is our original if-then statement. Okay, so here it says, if I studied really hard, then I earned an A on the test. Okay, so that is our if-then statement. That's our conditional. Okay, now the letters down here, what they use the letters to help summarize the if-then statement. S represents studied, and A for A on the test. The converse, look what happens. I'm going to jump right down here. The converse jumped and they switched it. Converse means to switch. So they switched the hypothesis and the conclusion. So they're talking about the A, getting the A on the test first and then studying. So look how it reads. If I earned an A on the test, then I studied really hard. So again, the converse is switching the conditional, just flipping the hypothesis and the conclusion. The inverse, we go back to the original. Do you see how it says S and A? Well, that's our original up here. And they put that little tilde in front. Remember, tilde means not or no. So here it says, if I didn't study really hard, then I didn't earn an A on the test. If I go back to the beginning, my original, if I studied really hard, how'd they change it? They added a not. If I did not study really hard, then I didn't earn an A on the test. The contrapositive, it takes the conditional and negates it. So what that means, here I can see right here, that's our second one, our converse, and it switches it and it makes it a not. If I didn't earn an A on the test, then I didn't study really hard. All right, so we are going to actually practice having these skills and being able to rewrite our sentences the 3 different ways after we have our conditional. So when I give you a conditional, you're going to be able to write its converse by switching it, write the inverse by putting no or not or did not, could not, have nots in it. And then the contrapositive is also going to be adding nots from the converse. So again, we're going to practice with this. Make sure you understand the 4 terms for this and the symbol of negation, that tilde symbol. All right, so when we go to class, we're going to practice these skills. Make sure you're aware of these words on the side.